this graph here, it'd probably be a little difficult to make an equation. Just a little. Chelsea?
You could just look at the graph.
You could just look at the graph, which, I don't know. Do you think that's easier than making an equation?
I would think so.
Yeah, I would think so too. So if this is x, there we go, x is 2. If you look on the graph, and I apologize, but this drives me crazy, that the lowest point here is supposed to be at 2, 8, and the curve doesn't match with the lowest point. So I need to fix that because it's drove me crazy all day. So just pretend that that's the lowest point of the curve there. It really is supposed to be the lowest point of the curve. Kind of fix it a little bit. So we have this graph. Here's the x value of 2. The y value is negative 8. So now I know that f of 2 is equal to negative 8 by looking at the graph. So then for number 3, it says for what approximate values, if any, does f of x equal 3? What are you really finding there? Chelsea?
What x value is along with the y being 3?
Good. Remember, anytime you see f of x, it's really y. So if you know y is 3, what's the x value that goes along with it? This one wants you to approximate. So they don't give you an ordered pair at that location. The y-axis is counting by 2, the x-axis is counting by 1. So kind of just trace your pencil, pen over, like I'd say approximately right there, which looks like it's a little before 4, but definitely after 3. So maybe negative 3.5, negative 3.75, you're approximating. As long as you have an answer between negative 3 and negative 4, you'd be okay.
Oh wait, never mind.
Question 3 says, give all the roots of f of x. So a root has 2 other names that are the same thing. Anybody know what a root is? A root is the same thing as a 0. What's a 0 the same thing as? Where the graph crosses the intercepts, yeah. And specifically the x-intercept, which means when is y 0. So that's called a root. It's called a 0. It's called an intercept. They all mean the same exact thing. Find y, or find x when y is 0. So, Alice, where's one point where it crosses the x-axis? At 1. So an x-intercept, 1, 0. How about another point, Alice?
-1?
Yep. And is there a third point?
-3?
Yeah, that sounds pretty good. So roots are the same thing as x-intercepts. Where does the graph touch the x-axis? Where does it cross through the x-axis? Any questions on those 3? So number 4 says, what is the solution set of f of x being greater than 0? This was a question that was in your book. It was like question 87, problem number 87 from section 1.3, I think. But instead, I think it said find the interval where y is greater than or equal to 0. So we looked at the part of the graph where it was above the y-axis, I'm sorry, the x-axis. So we want to find where the graph is greater than 0. Alice just told me all the points where it is 0. So now give me the interval where it's greater than 0. In this graph, it does say the domain goes from -6 to +7 in the direction. So I'll put endpoints there. It's going to stop at -6. It's going to start at -6, end at +7. So where is the graph greater than 0? Right?
Brackets -6 to parentheses -3.
Perfect, Brandon. Nice. So you put a bracket with -6 because that's where the graph starts. A parenthesis with the -3 because it says greater than. It doesn't say equal to. Brandon, how about the other part that it's greater than 0?
Parentheses -1 and then parentheses 1.
Perfect. Good. So you got this upper point or portion here, and then the little mound in the middle. Those are the 2 places where it's greater than 0. We're going to skip number 5. That's a composite function. We didn't really talk about that yet, so we'll skip over that one. We talked about them last year, but we'll go over them again. Number 6 says, on what interval or intervals is f of x greater than 5? Okay, so same exact question. When is y greater than 5 instead of y being greater than 0? So go to where your y value is 5. Chelsea, what piece is bigger than 5?
Bracket -6 to -4.
And that -4 gets a parenthesis because it says greater than. If it was equal to, then we put a bracket again. So all of this is one graph. We're just interpreting your graph. There's many things you can do with one little graph. Number 7 says, on what interval or intervals is f of x increasing? So look at your graph. Where is it increasing? Meaning the graph from left to right is going up. Brandon, do you have one interval where it's increasing?
-2 to 0, 2.
Okay, so he gave me the ordered pairs, which it's in between. So Brandon, when you describe it, you're going to use the horizontal distance, so the x values that it goes from.
So -2 to 0.
-2 to 0. They get parentheses. -2 is the lowest point, 0 is the highest point. So we're going to put parentheses around those values. Because we don't know if it's increasing or decreasing at that point. That's just where it stops increasing or starts. And then is there another piece, Brandon, that is also increasing?
Yes, 2, 7.
Yeah, from 2 to 7. Now, because the 7 is the end point of the graph, we could say that it actually does stop increasing there because nothing else is happening after that. It just stops at that point. Questions? All right, and then I think we're going to do number 8 and 9. We're going to skip number 10. So number 8, again, a little confusing what it's asking for. There's one important word. On what intervals is the rate of increase of f of x decreasing? I guess 2 important pieces here. Where's f of x decreasing? So the first one said, where is f of x increasing? Where is f of x decreasing? So if you look at the graph, where is f of x decreasing? So can you give me the horizontal interval?
0 to 2.
Okay, so here from 0 to 2, it's going down. And, perfect, -6 to -2, it's going down. So -6 to -2. Again, because -6 is the point where it starts, we can put a bracket around that because it begins at that point. And then she said from 0 to 2. And then the last question, we won't do 10, as I said, we'll just stop at number 9 here. For what values of f of x, or what values does f of x equal x? Chelsea, what does that really mean?
What values does y equal x?
Yeah, when does y equal x? When does y equal x?
At 2 or -2.
At -2, -2. Any questions? So we went through, we didn't do domain arrange there, it gave us the domain, but we did increasing and decreasing intervals, we evaluated using a graph. We were able to find a piece of the graph that was greater than a specific number, finding an interval of the graph that satisfied that condition. Are there questions on any of that? So then I'm going to go over one more problem with you, and it's actually from the first review worksheet. It's the piecewise function. Here we go. So there are 2 different review worksheets in there. I sent the solutions to both through Remind after school yesterday. But you can feel free to come up and take a picture of both sides. I think it's 5 pages of review. No, I'm not collecting it. I suggest that you look through and circle the ones that you don't know how to do. So just go through, circle the ones like right now by looking like you don't know how to do these, you feel uncomfortable with those. Focus on those tonight. And then maybe just kind of review the other ones, but you should definitely like look at ones and say, I need to focus on this. But there are 5 different pages in there for you to review. So make sure you look at all 5 pages. I think it starts at, what page are you on, Sabrina? Starts at page 25 and it goes to page 28, I think it should be, right here, 29. So it starts at page 25, it goes through page 29. If you look at the bottom of page 25, there is a piecewise function graphed for you. It says to write a definition for the piecewise function defined, for the piecewise defined function. It's a little wordy as well. Mr. Kane probably would like hack that up there. Also, find the domain and range. Each tick mark represents one unit. So if we're supposed to write a definition for this piecewise function that's kind of given to us, that's another way of saying write an equation for the function that you have. How many pieces are up here? 2. So how many equations should you have? 2. 1 for each piece of the graph that you see. So when we're writing a piecewise function, that's when we get to use those little squiggly things, my favorite thing to draw. Pick the piece on the left, look at it. What does it look like to you, Libby?
Half a parabola.
It looks like half a parabola. And that half the parabola is centered at the origin, so it's not shifting left, right, up, or down. Libby, what is the equation of a parabola?
X squared.
X squared. So that's the first part, that's the equation. Then you need to write its matching domain to say where is that piece of the graph existing for the x values. So Libby, where is it existing?
-2 is less than or equal to x is less than 0.
Excellent.
I did
You-
the same thing as Allison did last night.
Awesome. You could have also said, hey, I'd rather write it in interval notation because you like seeing interval notation. They mean the same thing. So it goes from -2 less than or equal to x because it's a closed circle, less than 0 because the 0 is an open circle. So now you have one piece done. Looking at the other piece, it's a line. Brandon, in a line, we need a slope and a y-intercept. So what do you have for that equation?
Just x plus, no, not x plus 1. Why am I having trouble with the regular line?
It's okay. Where's it crossing the y-axis?
Minus 1.
-1, yeah. So if you look at your point, it looks like rise 1, run 1, rise 1, run 1, rise 1, run 1. So I would fall 1, go backwards 1. There's a y-intercept. And then Brandon, can you give me the domain for that piece?
Parentheses 1 to infinity.
So he said parentheses, about bracket, 1 to infinity, or you could say x is greater than or equal to 1. Either one of those is fine. So if you're writing it as an interval, both should be intervals. If you're writing it as an inequality, both should be inequalities. Questions? And then the range, you were asked to just write separately. The range starts at the x-axis, which is our y value of 0, goes on forever because this piece here continues. Doesn't matter that the other piece stops. If one continues on, then that is included in the range. Questions? So again, there are 5 pages in there from 25 to 29. The solutions are up here, also posted to remind, but feel free to take a picture of the front and back. Don't forget about those sides. We have about 13 minutes. I think school time is like 1 minute faster than my MacBook time. So grab a partner, please ask questions. Reminder about the test tomorrow, no, you don't get any extra time. No, you can't come and make it up in homeroom. No, you can't finish it some other time. Yes, you have 40 minutes to take it. Yes, I'll give it right as you walk in. Keep track of your time. Don't get stuck on a problem. It's best to like skip a problem and come back to it and have 4 problems left that you didn't finish. They just spent too much time on 1 problem. 64 points. I did.
Why did I do it?
Okay, so this one here, if it's even, it has y-axis symmetry.
I don't know why.
So that means that your x values, you're just gonna make all the x values negative and then regraph it. It should look identical but flipped on the other side.
So just all the X's.
Yep, and then that's exactly.
This Kate's birthday.
Is it really? I hate our power school program. Like the old program, as soon as you like went to take attendance, it would be right next to me, like my birthday. I had no clue unless I would click on everybody individually. Which I don't like because I want to invite to attend.
I hate Power School. Power School never can wish me happy birthday because mine's in August.
Well, no, you're right.
It's so annoying.
I just with progress book, it was just like as soon as I
Oh, it was so much better. I hate Power School. It is so much better. I'm so mad at
yeah, they took that up too. Well, happy birthday.
Are we supposed to get GPAs back?
I don't know if they thought that was causing too much like anxiety.
No, I like want to know what I have.
Some kids want to know it because they want to know that you get into the honors.
It should be honest. I don't know why I did this, but I thought it. I don't know. That's weird. It's funny that both of us did it too.
Hey, you did all